Welcome to this explainer. Have you ever sliced into a melon, expecting a totally mundane seed harvest, only to find a literal jungle already growing inside? Well, today we're diving into a really fascinating botanical mystery involving the honey melon, or cucumis-melo if you want to get scientific, and what exactly happens when its seeds just utterly refuse to wait for spring.
I want to read you the exact words from the gardener who documented this. They wrote, "Little was I aware that once these seeds are detached from the placenta, they immediately sprout." I mean, imagine that. You slice into a sweet honey melon, expecting dormant seeds, and instead, boom, you're met with roots already springing into action. The author actually noted that some of these seeds sprouted rather long roots almost instantly after being harvested. It completely flips our whole expectation that seeds need soil, time, and, careful tending just to wake up.
Okay, let's dive into this, because every good micro-mystery starts right at the scene of the crime. And in this case, that's right in the core of the fruit. The gardener was just doing a routine harvest, scooping seeds out from the hollow center. But think about that environment for a second. It's a highly specialized, incredibly moisture-rich incubator. The very act of cutting into that space and scooping out the center, that is a massive, massive environmental shift for the plant's offspring.
To really understand this rapid sprouting, we have to look at the melon's anatomy, specifically the placenta. Now, botanically speaking, the placenta is that fibrous, thread-like network sitting right in the middle of the hollow center of the fruit. It's basically the tissue that connects the seeds to the parent plant, supplying them with exactly what they need while they develop. And the author made a really critical observation here. This immediate sprouting was triggered specifically when the seeds were detached from this fibrous network. It's almost as if that physical connection was the only thing holding them back. Once severed, it's like a biological switch was flipped, telling the seeds, "Go, it's time to grow."
So, faced with a sudden handful of eager sprouts with long roots, our gardener had to pivot. Instead of drying them for storage, they decided to sow them straight into some unused weathered seedling trays outside. Trays that, by the way, were exposed to the weather and already happily growing an impressive crop of weeds. But it was right before sowing, actually during the washing process, that a really intriguing observation was made.
Here's a question for you. While washing the batch of seeds, a clear division happened. Why did the sprouted seeds sink straight to the bottom, while the unsprouted ones just happily floated at the surface? Bouncing at the top were the dormant seeds, while those eager root shooters sank like stones. Now, if you spent any time at all in gardening circles, you probably know there's a very common rule of thumb about floating seeds. But, as we're about to see, nature is rarely that simple.
Now, what's really interesting about this slide is how it completely dismantles a very pervasive piece of gardening folklore. You've probably heard the myth, floating seeds are spoiled, dead, or hollow, and only sinking seeds belong in your garden. But let's look at the reality. Floating seeds are often perfectly healthy. They just haven't absorbed water yet. Our source text points out that many completely viable seeds float simply because their outer coat is still dry. They belong in the dirt, not the trash. They're just waiting for the right conditions to start their journey.
This brings us to a crucial botanical term, imbibition. It's the essential first step in germination, which is simply the process of water absorption by a seed. Basically, before a seed can grow a root or a shoot, it has to drink. The unsprouted seeds that were floating in the gardener's bowl just hadn't gone through imbibition yet. Their outer coats were still entirely dry and intact, essentially acting like tiny little life jackets, keeping them buoyant on the surface.
So the crucial point is, why exactly did the sprouted ones sink? Well, it comes down to a step-by-step anatomical breakdown of imbibition. Step 1, the root, also called the radicle, breaks through the seed coat. Step 2, that breach opens the floodgates, literally allowing water to rush into the seed. Step 3, all that incoming water displaces the internal air pockets that were acting as that life jacket. And finally, Step 4, without that air, the seed becomes heavy and sinks right to the bottom.
Okay, so if you want to preserve your own seeds without accidentally starting a melon farm on your kitchen counter, here is the exact game plan. First, you need to wash the seeds thoroughly to remove any lingering juices or pieces of that fibrous placenta. Second, dry them fast. You can pat them dry with a kitchen paper towel, or better yet, let them dry naturally under the hot blazing sun. Getting that moisture away quickly prevents unwanted imbibition and ensures they stay perfectly dormant.
Actually, this practical advice brought up a really relatable anecdote from the author's own life. Seeing these seeds prompted a memory of their parents, who always relied on the natural power of the sun to process their garden harvest. They would take vegetable seeds, and especially large ones like honeydew melon seeds, and lay them out to dry naturally under the blazing sun. The intense heat rapidly removes the moisture, halting any chance of the seed waking up and breaking its coat, which ensures it remains perfectly sound for long-term storage.
So back to our gardener, who sowed both batches into those weathered seedling trays. We already know the sprouted ones are well on their way. But will the remaining unsprouted seeds eventually wake up and join them? Well, we'll just have to wait and see. But it really leaves us pondering the resilience of nature. A simple slice into a breakfast melon reveals complex survival systems, precise growth triggers, and basic physics just hiding in plain sight. It kind of makes you wonder, what other microscopic dramas are playing out in your own backyard right now? Thanks so much for joining me for this explainer.